Okay, adding and subtracting rational numbers, aka fractions, right? The denominator of a fraction tells us how many pieces of the same size make one whole. So let me get my pen, sorry. So for example, if I were talking about this, the denominator would be 3 because 3 pieces make one whole circle. Okay. The numerator of the fraction tells us how many of these pieces we're talking about. So if I'm talking about how many of the pieces are shaded, the numerator would be 1. If I'm talking about how many pieces are not shaded, the numerator would be 2, right? So 1 out of the 3 pieces is shaded. So this is my fraction 1/3. The denominator is how many total pieces, or how many pieces make a total circle. Numerator, what you're talking about. Okay, in order to add or subtract fractions, the denominators have to be the same size. In other words, the pieces have to be the same size. If I can make the pieces of something I'm talking about, use your imagination if those are all same size pieces. So if I can make the pieces the same size, right, then all I have to do is count how many pieces I have. Okay, so once the pieces are the same size, you can simply add or subtract the pieces that we have, the numerators, and the size of the piece, the denominator, is not going to change. If the denominators are the same, we say they are alike, or that they are common denominators. If they're not alike, we must make them alike by finding the common denominator. There's many possible common denominators, but we always want our work to be as easy as possible, so we want to find the least common denominator in order to make our work as easy as possible. We already said that. A common denominator is a number that both of your denominators, or all of them if you have more than 2, of your denominators divide into evenly. A common denominator will always be at least as large as the largest denominator. In other words, a common denominator cannot be smaller than either denominator. To find the least common denominator, first, I would check the largest denominator to see if the smaller one divides evenly into it. If it does, that's your common denominator. So look at your biggest number first and see if that's it. If it does not divide into if the other denominators do not divide into your biggest one evenly, then we're going to use our prime factorizations to find the least common multiple, which is the same thing as the least common denominator. Okay? All right, so let's put all this together and do an example. Let's say we had 12 and 18 as my denominators, and I just want to know what the common denominator would be, right? What the common denominator would be. So I'm going to look at my biggest one, and I wonder, well, is it 18? It's got to be at least as big as the biggest. It can't be smaller than either one. Does 12 go evenly into 18? Nope. Then that's not it. That means we're going to find our prime factorizations. All right, prime factorizations. All right, so 2 squared times 3. Whoops. And 2 times 3 squared. Okay, so remember, I'm looking for the LCM, so I want the largest. So I'm going to take to find my least common denominator, I'm going to take everything that they have with the largest exponents. Okay, so 4 times 9, 36 is the least common denominator between 12 and 18. Let's do that again. What about 20 and 32? Is it 32? Does 20 go evenly into 32? No, no. So then I'm going to find my prime factorizations. Remember our prime factorizations? We're going to use them for a lot of things. All right, so I have 2 squared times 5, which is 20. And remember, I can start with any 2 numbers I think of. All right, this only has factors of 2, but there's 1, 2, 3, 4, 5 of them. So to find my least common denominator, which is the same thing as the least common multiple, I've got that L in there, which I'm going to think of as largest. So I'm going to take the 2 and the 5, and the biggest exponent on the 2 is a 5. Okay, so let's figure out what this is. Let's think about this. Let me give you a hint here. Anytime I've got 2's and 5's, let's put one of the 2's with the 5. That means I have 4 2's left, right? 5 of them I could split. Here's 1, here's 4. That gives me, that's still my 5 2's. But anytime I compare a 2 with a 5, look what happens. And look how much easier that might make our math. Okay, I didn't have 2's and 5's over here. Okay, so 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 10 times 16, 160 would be the least common denominator between 20 and 32. Okay, so that's how we're going to find our least common denominators, right? If it's not the biggest one, check that first because that's a huge shortcut. But if it's not, then do your prime factorizations and find your least common multiple, aka least common denominator. Okay, now we're going to use the least common denominator to make equivalent fractions. Equivalent fractions are fractions that have the exact same value as the one we're talking about, but different numerators and denominators. Like earlier when we were converting, well, no, we didn't do that. We converted mixed numbers to improper fractions, but same idea. 1 1/2 is the same thing as 3/2, except I don't want to go mixed numbers. I want to do equivalent fractions, and to be the same thing as like 1/2 is the same as 2/4, right? Those are equivalent fractions. They're equal the same amount, but they've got different numerators and denominators. And the way we do that is as long as we multiply the exact same number to the top and the bottom, notice what we would get here. 1 times 2, 2 times 2, right? So let's take these 2 denominators, and let's say we had 7/12 and 1/18, and I'm going to add them. I need to find my common denominator, which we already found. So I want to make both of these numbers have that denominator. Both of these numbers have the same denominator. So to do that, I just have to multiply this top and bottom by the same thing. So I have to figure out, well, 12 times what is 36? We might know it's times 3. We might just know that. So that would tell me to do the same thing. 7 times 3 is 21. Okay, and we might know that 18 times 2 is 36, telling me I've got to multiply the numerator times 2. But if I didn't, I can use these values up here. Okay, look what that gives me. Here's my 12. If I look across here, the 2 squared is the same. Oh, this one needs another 3. Look, needs a 3. That's how I knew to use a 3 here. If I compare it over here, right, the 3 squared's the same, but this one needs another 2 for it to look like this. That's why I multiplied by 2. Okay, now once your denominator is the same, it stays the same in your answer, and you just add how many pieces you have. You've now made these pieces all the same size, so that's going to be the size they stay. You just say, oh, and now I have 21 pieces this big. It's the same thing as having 7 pieces this big, but right, these are much bigger pieces. But now I've got 21 of them, and 2 of them, 21 plus 2, I've got 23 total pieces. Okay, let's do the same thing over here. Let's just say we had the same numerators, and let's say it was 7/20 plus 1/32. Okay, if I'm adding fractions, I need the denominator to be the same, and we have found this denominator to be 160. So that means both of these fractions are going to have a denominator of 160. Now 160 is a little bit bigger number than this 36, so here I might use that shortcut we were talking about. How do I know what to multiply 20 by? Well, let's look up here and compare. Look, this one has the 5 that this has, and it only has 2 2's though. This one has 3 2's. So I need to multiply by 3 2's. 2 times 2 is 4, times 2 is 8. Hey, that helps me figure out what to multiply by. 7 times 8 is 56. Okay, let's compare it with this one. Oh, look, 2 to the 5th, 2 to the 5th. What's missing is the 5 over here. I need to multiply by 5. Once the denominator is the same, it stays the same, and you add the numerators. 56 plus 5 is 61. Okay, so we're going to practice that a couple of times, but on this next slide, this is basically our instruction. So if you want to pause and read over that or copy that down, that's your steps that we just went over. Okay, look at the denominators. If they're the same, you're good to go. If they're not the same, find the least common denominator, make equivalent fractions, add or subtract the numerators, of course keep the same denominator, and simplify if possible. All right. So, are the denominators the same? Yes, yay! Keep the denominator and add the numerators. Okay, simplify if possible. As long as we divide the exact same thing from top and bottom or multiply. Right? So 6 divided by 2 is 3. 8 divided by 2 is 4. Okay. Are the denominators the same? No. If they're not the same, look at the biggest one. Does 4 go into 12? Yes, it does. So I know my denominator is going to be 12 on both of them. It's got to be at least the biggest one. Since I did not change this denominator, don't change this numerator. But this one, I've got to make that 4 a 12. So I know that 4 times 3 is 12, so 1 times 3 is 3. All right, now once the denominator is the same, that's just what it is in the answer. And I add and subtract the numerators. The signs are different, means minus. 5 minus 3 is 2. Keep the sign in front of the biggest number. Now, both of these are divisible by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. Okay. Are the denominators the same? No. Is it 15? Does 10 go into 15 evenly? Is 15 divided by 10 a whole number? No. Okay. Then let's go find our prime factorizations of 10 and 15, which is pretty easy. 2 times 5 and 3 times 5, right? Two times 5 and 3 times 5. So because it's got the L in there, the LCD, I want the largest amount of them, all with the largest exponents. Okay, so this is it. 2 times 3 is 6 times 5 is 30 is my common denominator. I need to make both of these have a denominator of 30. Now in this we can probably tell that 10 times 3 is 30. So I need to do 7 times 3. And 15 times 2 is 30, so I need to do 7 times 2. If not, I could compare 10. Oh, what's missing is the 3. And 15, oh, what's missing is the 2. Right? Once the denominator is the same, it stays the same, and you just add or subtract numerators. So what would that be? 35? Hey, both of these are divisible by 5, both numerator and denominator. So 7, 6. Okay. Oh, denominators are not the same. Is 24 divided by 20 a whole number? No. All right, that's fine. Just go over here and find your least common multiple. I'm going to erase some of that. Actually, if you're not done with this, pause it. Okay, because I'm going to erase everything just to give me some more room. Okay, so maybe what? 2 times 10. And 2 times 5. And I get 2 squared times 5 for the prime factorization of 20. And for 24, we get 2 cubed times 3. So I'm going to take everything, the 2's, the 3's, and the 5's, and the largest exponent on each one. Okay, so hey, once again, look, if you, sometimes like this is 8 times 5 is 40, times 3 is 120. Some of us can do that. But if we're not really good at doing math in our head, don't forget a great method is in anytime you have 2's and 5's, let's put one of the 2's with each 5. Now that's still going to leave a 3 and 2 more 2's, right? Does that make sense? Here's my 3. Here's my 5. But all of these 2's, I split them apart and put 2 of them over here and 1 over here. Right? That's still 3 2's, but now I can tell that this is 10 times 3 times 4 is 12 for 120. So my common denominator is going to be 120. Both of these have to be 120. If I can't tell what number to multiply 20 by to make 120, go back up here and look at, here's my 20, and compare it. It needs a 3 and one more 2. 6. I'm going to multiply this by 6. 3 times 6 is 18. Oh yeah, 20 times 6 is 120. Let's look at the 24. Okay, I've got all the 2's and the 3. Oh, it's missing the 5. 7 times 5 is 35. Now, once the denominator is the same, it stays the same. One's positive, one's negative, so we minus. 35 minus 18 is 17. Keep the sign in front of the larger number. Don't forget to see if it'll simplify, but that will not. 17 only has factors of 1 and 17, and 120 is not divisible by 17. Adding and subtracting rational numbers. Awesome.